Welcome to this explainer. Today, we're going to decode the mechanics of humanity's most common natural disaster. We'll uncover why something as totally ordinary as rain can, well, entirely disrupt the global economy. I mean, floods actually affect more people every single year than earthquakes, volcanoes, and tsunamis combined. But how does this actually happen?
Okay, let's dive right into this with a pretty terrifying statistic. Up to 4 million people perished in the 1931 China floods. That marks one of the deadliest natural disasters in all of recorded history. Now, when we hear a massive number like 4 million, it's kind of hard to even comprehend, right? We often think of floods as just a nuisance, some extra water on the road. But historically, when major rivers breach their banks, entire regions and literally millions of lives are instantly reshaped.
It's important to understand the raw power of water at play here. Just 15 centimeters, that's about 6 inches, of fast-moving water is all it takes to instantly knock an adult completely off their feet. It is incredibly deceptive. You might look at a flooded street and think, oh, it's perfectly safe to cross. But water is incredibly heavy, and it is absolutely relentless. So, how do we get from a peaceful rain shower to a force capable of sweeping away everything in its path?
Section 1. Flood Mechanics, Nature's Balance. Let's move to our first core concept and see how the baseline equilibrium of our planet's water cycle operates before it gets severely disrupted.
So, this continuous cycle is nature's balance. The sun heats the oceans, water evaporates, clouds form, rain falls, and then that water naturally flows right back to the oceans through rivers. It's a perfect system. But floods occur when this exact sequence becomes temporarily overwhelmed. Think of massive weather systems, like intense monsoons, tropical cyclones, or atmospheric rivers, just dumping way more water onto the land than the natural topography can possibly handle at one time.
And that leads to a cascading failure. It's basically a chain reaction. First, heavy rainfall pounds the earth. Soon, the soil acts like a sponge that just cannot hold another drop. It becomes completely saturated. Once that happens, surface runoff increases drastically. The water just runs over the land, totally overwhelming urban drainage systems and filling up streams. Finally, with literally nowhere else to go, the riverbanks overflow and the water spreads out, damaging infrastructure and destroying homes.
Section 2. Types of floods. Different forms. Not all floods behave the exact same way, so let's break down the different forms this destructive force can actually take.
The really crucial point to grasp here is the massive contrast in pacing. Flash floods are triggered by intense rainfall, usually over steep terrain or hard, concrete urban surfaces. They are rapid, dangerous, and instantly lethal with almost no warning. You literally have minutes to escape. Conversely, river floods, also known as fluvial floods actually, happen after prolonged rainfall over a massive drainage basin, kind of like the Mississippi River. They're a slow, massive, and inevitable creep across huge areas. They usually give us days or even weeks of warning.
But beyond rivers, modern development has created entirely new risks. Coastal floods are driven by storm surges and sea level rise. Meanwhile, our modern cities face unique vulnerabilities like urban waterlogging. This happens because all that concrete and asphalt prevents water from soaking into the ground. We also have to consider catastrophic dam break floods. And up in the Himalayan regions, communities are increasingly threatened by glacial lake outburst floods, where warming temperatures cause a sudden, super violent release of glacial meltwater.
Section 3. Economic impacts, global consequences. Now, let's zoom out a bit to understand the massive geopolitical and financial stakes when these waters rise, because flooding is far more than just an environmental issue.
Looking at the historical data, it's super clear that flooding is not just a localized weather event. It's a massive global economic shock. Just take the sheer scale of the 2022 Pakistan floods. Driven by record monsoon rainfall and glacier melt, it affected over 33 million people and caused more than $30 billion in losses. Events like this wipe out critical infrastructure, destroy crops, and force mass migrations that ripple all across borders.
To put that into an investor's perspective, let's look back at the Thailand floods of 2011. A single season of intense monsoon rainfall caused roughly $45 billion in damage. That's billion with a B, but the impact didn't stop at Thailand's borders. No way. Those floodwaters completely halted global electronics and automobile manufacturing for months. Warehouses were destroyed, ports were shut down, and the entire global supply chain was totally choked.
Now, what's truly fascinating here is how capital actually flows after a disaster. It is a complete economic reshuffling. On one hand, industries like agriculture, tourism, and logistics face devastating immediate losses, and insurance companies get hit with billions in claims. But conversely, the demand for construction materials, heavy engineering services, and water management infrastructure immediately spikes as that long process of disaster recovery and rebuilding begins.
Let's look at a specific geographic focus: India. Because of its incredibly complex mix of geography, we're talking intense monsoon rainfall, massive river systems fed by Himalayan glaciers, and a really long coastline exposed to cyclones, India is exceptionally vulnerable. Add to that rapid urbanization, where cities are literally encroaching directly onto natural floodplains. This is exactly why regions like Assam, Bihar, and major cities like Mumbai are uniquely and highly prone to catastrophic flooding year after year.
Section 4. Engineering Solutions. Fighting Back. So how exactly are scientists and engineers fighting back against nature's most destructive force? Let's check out the solutions.
Today, we rely on a highly strategic mix. On one hand, we use brute force physical infrastructure, massive concrete dams, levees, and flood barriers specifically designed to hold back the water. But engineers now realize we can't just fight nature, we have to work with it. That's why we combine those rigid barriers with vital nature-based solutions. Things like restoring wetlands and conserving mangrove forests, which act as natural sponges to safely absorb excess storm surges right before they hit our cities.
To stay one step ahead, scientists use something called hydrodynamic simulations. And this is fascinating tech. By combining real-time satellite data, weather radar, and Internet of Things sensors placed directly inside rivers, these advanced computational models can accurately map exactly where the water will go, how fast it's going to move, and exactly which neighborhoods will be inundated. Looking forward, the technology is getting even more sci-fi. Artificial intelligence is now being used to predict rainfall patterns with unprecedented accuracy. We're even creating digital twins, which are exact virtual replicas of entire river basins and cities, to simulate flood scenarios before a single drop of rain even falls. This technology is absolutely revolutionizing disaster management. It buys citizens precious extra hours to evacuate, and even allows autonomous rescue drones to map out safe paths.
Section 5. Surviving the flood, myths and facts. Finally, let's bust some dangerous myths and look at exactly what you need to do to survive when those waters inevitably rise.
So, you hear this phrase on the news all the time, right? The 100-year flood. But honestly, it actually causes a lot of deadly misunderstandings, mostly because people take the term way too literally.
Here is the truth. A 100-year flood absolutely does not mean you're safe for a century. It's just a statistical probability. It simply means there's exactly a 1% chance of an extreme flood of that magnitude happening in any given year. And yes, because weather is chaotic and the climate is changing, 2 100-year floods can absolutely happen back-to-back within the exact same decade.
And please, keep this crucial comparison in mind, because it's literally the #1 mistake people make. The myth is that heavy, modern SUVs can safely drive through a flooded street. The terrifying fact, though, is that modern vehicles provide a completely false sense of security. Just 60 centimeters, about 2 feet, of moving water is more than enough to lift a heavy passenger vehicle right off the road. It basically turns your expensive SUV into a very heavy, uncontrolled boat.
Ultimately, your best defense is preparation and an absolute respect for the water. Before a flood, know your local risk and have an emergency kit ready to go. During a flood, immediately move to higher ground, and whatever you do, never walk or drive through moving water. And after the storm passes, beware. Floodwater isn't clean rainwater. It is highly contaminated with sewage, chemicals, and hidden debris. Always boil your drinking water and stay well clear of any damaged electrical lines. Floods are humanity's oldest natural disaster, and as our cities grow and our climate shifts, they're becoming an even greater challenge. While we can engineer smarter cities, build massive infrastructure, and forecast extreme weather with advanced AI, we're left with a really vital question to ponder. Are we adapting fast enough for a future where the natural balance of water is permanently changed?
Thank you so much for exploring the science, economics, and immense impact of flooding with us in this explainer. Until next time, remember to learn, think, and grow.